let's start Hadoop development. Do you have any idea what is Hadoop? We can process huge amount of data. We can store huge amount of data, right? So first, Hadoop is a big data processing system, right? Hadoop is a big data processing system. And what is big data? Any idea? Okay, huge amount of data. Just now started. It is 3 V's: velocity, volume, variety, like petabyte. Okay, so there are different definitions. First one, big data means it's a huge volume of data. It is a huge volume of data which cannot be stored, which cannot be stored and processed using traditional technologies, using traditional technologies like RDBMS and application programming, application programming within given time, within given time. So we cannot store these huge volumes of data by using RDBMS. So huge RDBMS cannot support huge volumes of data. We cannot store huge volumes of data in RDBMS, and we cannot process that data by using application programming within short time. So this kind of data is called big data. Okay. RDBMS cannot support unlimited data. RDBMS cannot support unlimited data because let's see architecture of RDBMS. So RDBMS follows client server architecture. RDBMS follows client server architecture. So we can take some missions as master and some missions as slave missions. Some missions as masters and some missions as slave missions. So in this architecture, these are called masters and this is called slaves. So this concept is called cluster. Cluster means group of missions. Group of missions. Collection of missions or group of missions is called cluster. So we can create a cluster. So here RDBMS cluster maximum RDBMS cluster size. For Oracle, the popular database Oracle, maximum we can take 256 missions. 256 missions in cluster. MySQL maximum it supports 128 missions. The popular warehousing databases like Teradata, Vertica, Vertica. These databases maximum we can take 512 missions in cluster. 512 missions in cluster. So there is a limit in cluster. There is a limit in cluster. That's why. So there is a limit in. There is limit in cluster size. Cluster size. So we cannot store unlimited data. We cannot store unlimited data. We cannot store unlimited data in RDBMS cluster. If you come into Hadoop cluster, Hadoop, Hadoop also follows master-slave architecture. We can take some missions as master and some missions as slave missions. Slave missions. We can take some missions as masters and some missions as slave missions. So here you can take unlimited slave missions. There is no limit in cluster. There is no limit. You can take unlimited. Hadoop supports unlimited storage. Unlimited storage. There is no limit in. There is no limit in Hadoop cluster. We can take n number of missions. We can take n number of missions in Hadoop cluster. So there is no limit in Hadoop cluster. That's why we can store unlimited missions into unlimited storage into Hadoop cluster. So this is first advantage. But Hadoop supports what? Hadoop supports unlimited storage. Unlimited storage. Coming to processing. See, RDBMS, RDBMS is not distributed system. RDBMS is not distributed storage. So processing will take time. So if data is less, so if data is less, if data is less, processing is fast. Processing is fast. If data is high, or huge, then processing is slow. Processing is slow. Let's see how data is going to store in Hadoop, sorry, RDBMS. Assume we want to store 10 GB file. We want to store 10 GB file. 10 GB file. So first request is passed to master machine. Master machine verifies free slave machine which has 10 GB. Master machine verifies slave machine which has 10 GB. Assume first mission accepted request. So in this first mission we store 10 GB. So first mission has 10 GB space. First mission accepted request to store. So 10 GB stored into in this mission. In this mission. So next time user wants to read. So this is write request. This is write request. Next time user wants to read. So again read request goes to master. Read request goes to master and master verifies which mission has file 1. Then master send request to this slave 1. Slave 1 is responsible to process this entire request. Slave mission is responsible to process this entire 10 GB data. So to process this 10 GB data, it will take time, right? So single mission is responsible to process your 10 GB data. But coming to Hadoop, same 10 GB file, write request, same 10 GB file, we want to write, right? So file size is 10 GB, 10 GB file. So request goes to master. Here master prepares some information and divides a file into multiple blocks. In Hadoop, data is distributed. So data is split into multiple small chunks small chunks bracket blocks. So this block size is depends upon the configuration files. So default block size is until Hadoop 1.x versions, until Hadoop 1.x 64 MB, until 1.x 64 MB. From 2.x onwards, it is 128 MB, 128 MB. So 10 GB by 128 MB, 10 GB by 128 MB. How many blocks? 12, 10 GB. 1000 MB equal to 1 GB, right? So around assume around 80 blocks, right? Around 80 blocks. So 80 blocks are placed into different missions in cluster. So first block, second block, third block, like this data is placed into across the cluster. So your 10 GB data split into multiple blocks and distributed into multiple missions. In RDBMS, data is stored in a single mission because RDBMS is not distributed. RDBMS is not distributed, but in Hadoop is data distributed and stores in across the cluster. So data splits into multiple blocks and blocks are stored into different missions in cluster. Next, read request comes to master. Assume read request comes to master mission. If read request comes to RDBMS master, RDBMS master assigns works to only one mission, right? So 10 GB processing work is done by one mission. But here 80 missions parallelly processing your data. So if data size is less, we see very fast in RDBMS. If data size is huge, processing will take time. But here Hadoop data size may be any size, processing speed is very faster because processing is done by multiple machines in Hadoop cluster because of distributed data. Yep. See, you are saying you have 10 GB data. So 10 GB data of employees. Assume 10 GB data of sales data, right? So in this 10 GB data, you want to display Hyderabad sales, right? So in that 10 GB only, in that 10 GB, we have Hyderabad sales. So without processing 10 GB data, we cannot get Hyderabad data, right? So we after processing in that 10 GB only we get Hyderabad details. Yes or no? So coming to RDBMS, single mission is processing your entire 10 GB data. But here 80 missions are parallelly processing your data. So data is processing is very faster because of parallel processing. Okay. Yep. So RDBMS is not distributed storage, so data is not parallel processing. But Hadoop process data in parallel processing. Parallel processing. Data in parallel processing. So, so storage purpose we have HDFS file system, and processing purpose we have MapReduce algorithm. MapReduce algorithm. Hadoop has two core components. Hadoop has two core components. Two core components. Two core components. Storage, HDFS. Processing, we use MapReduce algorithm. GFS. Yep. File system. Yep. So HDFS is a Hadoop distributed file system. Hadoop distributed file system. HDFS is a Hadoop distributed file system. It supports unlimited storage. It supports unlimited storage. It supports parallel processing. MapReduce is an algorithm to retrieve processing. MapReduce is an algorithm to process the HDFS file system data. HDFS file system data. So MapReduce process data in parallel fashion. MapReduce process data in parallel fashion. Yep. No, no. Here we can store data unlimited. This is storage part. So here we have a limitation in RDBMS, right? We can take maximum of 256 missions in Oracle. But here we can take unlimited missions. In that missions we can store data, right? So we use file system for storage data. So what is the file system we use is HDFS file system.
At any time we can increase the machines.
Yep.
Any machine crash, then how the data will be taken.
Yep. So one of our student asking fault tolerance.
Yes.
If any mission crashed, what will happen in Hadoop? Sorry. What will happen? Hadoop is highly fault tolerant system. Hadoop is highly fault tolerant system. How Hadoop achieves fault tolerance, we'll see clearly. So to achieve fault tolerance, it uses a replica concept. Replica. Replica means it maintains duplicate copies. Duplicate copies of blocks. How it maintains duplicate copies, we'll see in architecture. Okay. So I'll explain HDFS file system architecture. Then you will understand how Hadoop achieves highly fault tolerant system. Okay. So MapReduce is a algorithm. Algorithm. We can implement this algorithm. We can implement implement this algorithm using many languages. Using many languages like Java, Python, C, C++, etc. It supports many languages. It supports many languages. You can implement this MapReduce algorithm using Java or Python. Popular popular is Java and Python. Popular MapReduce implementation languages are Java and Python. So to implement a MapReduce, we use any one language support. Any one language support. So you can implement a MapReduce in Java. You can implement a MapReduce in Python. So to implement a MapReduce, we need to have knowledge on any one language. Any one language. So so uh, Hadoop has Hadoop also has also has some frameworks some frameworks some frameworks like Pig, Hive. So these two are processing frameworks. So Hive is like SQL kind of scripting scripting language, and Hive also Hive also has similar SQL kind of query language, kind of query language, SQL kind of query language. So if you feel uh, language is difficult, language is difficult, we have some other frameworks in Hadoop which makes easy for implementation of queries. So instead of writing lengthy programs, we can write small scripts or we can write small queries to process your HDFS file system data. So if you feel MapReduce implementation is takes time and learning will take time. So if you feel Java or Python is difficult, we have other framework support like Pig and Hive. So these are simple SQL kind of languages. So simple query languages. So here we can write simple scripts. Example, example. I want find uh, sum of salaries of or find find sales sales district wise district wise. I want to find sales district wise. So to implement this one using Java or Python, Java or Python may take. So here may you write 50 lines of code, 50 lines of code. Same thing we can implement by using Pig or Hive, maximum of 3 to 4 lines, 3 to 4 lines of code, maximum of 3 to 4 lines of code. I'm writing simple Hive query, Hive query. Observe, in Hive I am writing one simple line of query to find uh, sales district wise, district wise. So here select district or city, district, comma, sum of sales, sum of sales from sales data, sales data, sales data, group by district. Maximum we are writing single line code, right? Single line code. Same thing to implement the same thing. It may be Java, it may be Python. Minimum it will take 50 lines of code. 50 lines of code. Because here in Hadoop, we write three kinds of programs. One is driver program, and mapper program, and reducer program. So we write three programs to implement MapReduce algorithm. Three programs to implement MapReduce program. So these three programs minimum it will take 50 lines of code. But in Hive, to achieve same thing, we use single line statement, right? Single line. How much time it will take? Maximum of 1 minute or 2 minutes. But here we need to have an idea on any one language. Otherwise, we cannot write these programs, right? So first of all, we need to have command on these two programs or any other program. Hadoop supports many programs, programming language. So mostly used Java and Python. So we need to have any one language support. Otherwise, we cannot write MapReduce implementation. So these are lengthy code. But if you use these frameworks, Hadoop frameworks are taking very less code. And one important to note, Pig and Hive queries internally converted to internally converted to MapReduce. MapReduce programs. We are not writing MapReduce programs. Hadoop will take care to convert your Pig and Hive queries into MapReduce programs. Finally, whatever the statement we written, right? This statement internally converted to MapReduce only. MapReduce program. Okay? But we are not writing. It is taken care by Hadoop. And we have some other frameworks, ingestion frameworks, data ingestion frameworks. Scoop and Flume. Scoop imports data from any RDBMS, to Hadoop. So if data is already presented in RDBMS, here we can use Scoop. We can use Scoop. What Scoop do? Scoop connects RDBMS system and imports data into Hadoop. Okay. So Scoop imports data from any RDBMS to Hadoop and exports Hadoop data into exports Hadoop data into any RDBMS. So Scoop will do only two operations, importing and exporting. Sorry. So here one student question is, already we have data in RDBMS. So RDBMS has data. So from RDBMS we are importing data into Hadoop system by using Scoop concept. by using scoop we are importing, right? So we are importing data into Hadoop. So this is Hadoop system. So this is RDBMS. From RDBMS we imported. We import the data into Hadoop. So data presented in Hadoop on HDFS file system, right? HDFS file system, we store data. But after processing this data, after processing, result may be very less, right? Result, we get result. So we store result back into, we store this result back into RDBMS. We store this result back into RDBMS. So your question is, why we are storing back this result back into RDBMS? Assume there are some applications which are already connecting to RDBMS systems. So there are some existed applications. There are some existed applications. Existed applications uh, connecting RDBMS. So instead of changing this logic, then we are storing result back into RDBMS. Okay. So we are exporting data to RDBMS. We have future, import and export. So when we export Hadoop data to RDBMS means, so after processing, result we store back into RDBMS. Hello, are you getting audio? Hello, yep, yep. So there is another framework, Flume. Flume imports data from streaming system to Hadoop. Just it imports data from streaming system or source to Hadoop. What is streaming? Yep. So if any continuous data, right? Continuous data is called stream. If any source generating continuous data, then we call streaming source. Streaming source. Example, web server, web server continuously generates logs. Generates logs. So cams continuously writes data into files. Sensors continuously writes data into files. Same as GPS systems continuously writes data into files. So if any source continuously generating, we connect that data source by using Flume. Then this Flume connects to that source and writes the data into Hadoop. Once the data presented Hadoop, then we can write either MapReduce, Pig script, or Hive query to process that data. Okay. So to process that data, we use MapReduce, Pig, or Hive. Okay. Next, one more tool we use Oozie. So this tool is for defining workflows and scheduling scheduling workflows. No, Hibernate or Hadoop? Hadoop. Yeah. I thought Hibernate. Same. Hadoop, right? Yep. Scheduling workflows, defining workflows and scheduling workflows. So what is workflow? What is workflow? Workflow means sequence of jobs. Sequence of jobs. Example, MapReduce jobs, MapReduce job, Pig job, Hive job, Scoop job, etc. So we have MapReduce 1, comma. Next one, first we are reading data using Scoop job. On that data we are applying MapReduce processing or Pig processing, and finally we are storing into Hive job. So we are executing this sequence. First we want to execute Scoop job. Next I want to execute MapReduce or Pig job. Finally I want to execute Hive job. So I want to execute this flow. So we can define this workflow. We can define this workflow. We can define this workflow using Oozie. So first I want to execute Scoop job. This Scoop job output become input to any one of these programs, and after processing this program output become input to this job. So we want to define this workflow. We can define this workflow by using OOSI. And what is scheduling? What is scheduling? No, no. Already we define, right? In this workflow, we define sequence. So, time. When you want to execute this workflow, when you want to execute workflow. So, time and repeatedly. So, I want to execute this workflow every day at 9 p.m. So I want to execute this workflow, complete workflow every day at 9 p.m. Then we can do scheduling. So we can define workflow. For that workflow, we can schedule. So these two operations we can apply by using OOSI. Okay? Job scheduling, job scheduling, or workflow scheduling. So here, as part of our Hadoop course, first we'll discuss HDFS file system. So this is very important. Next we'll discuss MapReduce brief, because nowadays no one using MapReduce. So that's why we just less concentrate on MapReduce. What is MapReduce architecture? We write simple MapReduce application. Okay. Next one, pig. Pig also no one using nowadays. No one using nowadays. So that's why we discuss it briefly. And we concentrate more on Hive. It is huge demand. Why it is huge demand? We'll discuss in Hive discussion. So we discuss in-depth Hive. Next, we discuss Scoop. Scoop is very important. And next one, we discuss briefly about Flume. So less uses. So that's why we concentrate on briefly about Flume. So instead of Flume, what we are going to discuss, uh, we discuss Kafka concept. So we discuss Kafka in weekend. So it is most demanding technology. Around we spend uh, 8 plus hours. 8 plus hours on Kafka. Messaging purpose. Streaming and messaging. It can do both streaming and messaging. And we discuss mainly OOSI. So as part of Hadoop course, we discuss all these concepts. There is one more concept, NoSQL concept. NoSQL, NoSQL databases are alternative to RDBMS. So we discuss NoSQL databases. Maybe we have a plan, 10 days workshop. So 10 days workshop we cover some NoSQL databases. Okay. So first we completed this workshop. So in this workshop we cover HDFS, briefly MapReduce, and briefly Pig, and in-depth Hive, in-depth Scoop, and Uzi. Flume we discuss briefly. Okay. So this is our course. So it will take around 20 hours. So every day class time is 8:30 to 9:30 a.m. So this is complete free training. So for this free training program, we cannot provide any recordings. First of all, we cannot record these sessions. So we cannot provide any free videos to this program. Okay. And every day I explain notes in this way. So try to write these notes. And this one is complete practical program. Practical. Complete practical. So only theoretical part is HDFS file system. If you get clear understanding of HDFS file system, then everything is processing only. Okay. So complete practical part. Next, installation. Additionally, I'll take 3 hours of installation part. So for our practice purpose, I'll explain first Cloudera installation. And Cloudera is simple installation. Next, Apache installation may take minimum 2.5 hours. Apache installation. So this I will explain in one weekend, any Saturday or Sunday. Okay.
There is a tool that we can install in our local system.
Yep.
And from local system we can manage with it. But with
Yep. You can know local system only. Yep. Yep. I'll tell you. So we are not providing any notes. We are not providing any videos. So you try to write these notes parallelly. No, for a complete Hadoop we are giving free. There is no cost for Hadoop. We are planning to give this Kafka also free workshop. We are planning to give NoSQL also free workshop. So NoSQL mainly we are planning to cover Cassandra, HBase. These are main important one. MongoDB. That's it for today. We'll meet tomorrow. Thank you.